All right, so this is day one of bearing and navigation. So this first box here that's bubbled, it says, in navigation and surveying, directions are usually given in terms of bearings. There's two common ways to express bearing, which bearing is another word for direction. So in method one, so a lot of times it'll say either method, it'll say both methods. So in method one, bearing is an angle measured in degrees clockwise from due north to the line of travel. So for example, here's our example. So here's due north. Remember your directions: north, east, south, west. I like never eat soggy Wheaties. There's never eat soggy waffles to help you remember. But 0 degrees is not at the positive x-axis like on the unit circle. 0 degrees is at due north. And then you're going to go clockwise. So this is 90 degrees. This is 180 degrees. And then this would be about 240 degrees. So knowing that that's 240, it's also to know, what's also important to know is what this angle is and what this angle is. So since straight down is 180 degrees, that would make this a 60-degree angle right here, and that would make this 30 degrees since that's a right angle together, okay? All right, so let's sketch some bearing here, sketch each bearing. So the first one is 325, so you're gonna start at 0 degrees, which is at due north, okay? And you don't have to put an arrow right there, but that's where you're gonna start, okay? Then you're gonna go clockwise. This is 90 degrees, 180 degrees, 270 degrees, and now we need to go 325 degrees. So I'm going to put a stopping point, which is my terminal side here, okay? And I know at some point in here I'm going to get to 325. But what you're going to want to do is you're going to want to label these two acute angles right here. All right, so I need to figure out how much more is 325 than 270. That is 55 degrees more, so this angle is 55 degrees. If this is 270 and this is 325 is what I'm saying. That has to be 55 degrees. And then the other angle, 90 minus 55, is 35. So this is 35 degrees, and you want to label both of those. All right, here's the next one. We're going to start at due north, and we're going to go clockwise. This is 90 degrees, and I don't want to go this far because that's 180, and I'm only going to 160, so I'm going to stop short of that. And when I do that, I have 20 degrees until I get there. That makes this 70 degrees here. Or you can think of it as 90 plus 70 equals the 160. Okay? That's how you draw those angles. So you're going to start from due north. So bearing right here. You start from due north, and then you go clockwise. Okay, you got to get used to that because we used to start at the positive x-axis and go counterclockwise, but now we're starting due north and going clockwise. All right, method 2, bearing is an acute angle that makes a path with a fixed north-south line. So it always starts either from north or south. So if you look right here, this is closer to south than it is to north. So it's going to start at south, and then you're going to say which direction you're heading towards. We're heading towards west, right? So this is south, and then since whatever this angle is, that's the angle that you use. That's south. 60 degrees west. South, 60 degrees west. Let's go back to the ones that we've already done to make sure you understand how we would write these in bearing. In this second method here, which is still bearing. All right, let me change color so it doesn't look, so it looks like it's not part of it. So this right here is closer to south than it is to north. So south, and it always either starts with north or south. And it's going towards the west. So that's west, and then you just say what that angle is right there. So that's south, 60 degrees west. If you look at this one right here, this one's closer to north than it is to south. So this would be north, and then it's going in this direction from north. Now, if you're like, wait, how do you know what direction it's going from north? Well, you said you're closer to north, and then you just have to go towards that terminal side. So north, 35 degrees. And then it's going towards the never eat soggy Wheaties. It's going towards the west. So north, 35 degrees west. Never eat soggy Wheaties. I have to do it every time. This is closer to the south, and then from south you go this way, so that's 20 degrees towards the east. Okay, let's try these two right here. We're going to try sketching them. I want north 42 degrees east. So I start at the north and I go towards the east, so that's this way. And then I go from the north towards the east. So from the north towards the east is this, and that would make that angle 42 degrees. And then I also want to label the other acute angle. So 90 minus 42 is 48 degrees. So I'll label this 48 degrees. South, 10 degrees east. So I'm going to start from the south, go towards the east. That's this direction. So I'm going to have a terminal side here. I'm going towards the east, and I'm only going 10 degrees. That would make this 80 degrees, and that one's done. All right, let's also check to make sure that we can write it like this on these three right here. So this one right here, remember, if we want to know what it is with bearing from due north, we go north clockwise. So this angle right here, north clockwise, is 42 degrees. So if I wanted to write this in the other manner, it'd be 42 degrees. This north clockwise until I hit that would be 90 plus 80, so that'd be 170 degrees. So you can do it either way. Sometimes one way is better than the other. All right, so this one is doing exactly what we were just doing. State the bearing of the pictured path using both methods. So I need my never eat soggy Wheaties drawn in. All right, so method one, from clockwise due north. So I want to know how many degrees this is right here. So you can see that that is 270 plus 40, which is 310 degrees. Once again, that's from 270 plus 40 more. All right, now I want to do it from the other method. And I have to say, okay, let me get rid of this right here. Which one is it closer to, north or south? It's closer to north. And then I have to go this direction to get there, so that's towards the west. And then you know how many degrees this is. This has got to be 50 degrees right here to make 90. So north, 50 degrees west. All right, so now we're going to do this to do some bearing and navigation. We're going to use this, not do this. We're going to use this to do some bearing and navigation problems. It says round all angles to the nearest tenth and round all lengths to the nearest hundredth. So I'm going to have a hard time remembering to do that because I'm so used to 3 decimal places, but I'm going to try my best. All right, now I'm going to do it correctly. All right, so it says a plane takes off from Midway Airport with a bearing of 25 degrees. After flying for 1 mile, the plane turns 90 degrees towards the northwest. State the new bearing by both methods. So I want to know, after I'm done drawing it, I want to know what's the new direction using both of my methods. All right, so this is the first thing I'm going to draw. A plane takes off from Midway at a bearing of 25 degrees. So what I need to do is I need to draw a compass. So I'm going to start by drawing a compass right here. X-axis and Y-axis. I draw the Y-axis first, but I always say that. All right, now I want to draw 25 degrees. Okay, so now remember, this is north right here. So I'm going to go clockwise 25 degrees. And you want to be pretty accurate. You don't want to put it in the middle. You want it to look like closer to 25 degrees than to 45. So I'm going to put it like right here-ish. I'm going to make it a little bit longer. And then I'll put 25 degrees right here. I'll also fill in my other angle. 90 minus 25 is 65 degrees, just in case I need it. Okay? All right, so now it says, the next sentence says, very importantly, and that didn't make sense, after flying 1 mile, the plane turns 90 degrees towards northwest. So notice there's now a new direction. So since there's a new direction, I have to draw a new compass, and I want the origin to be right here because that's where the plane is right now. So the plane's right there. So from there, I'm going to draw a new compass. I can't decide if I should use pink or not. I'm not going to. I'll use a different color completely. So I'm going to draw a completely new compass, this green, brand new compass. Never eat soggy Wheaties. Okay. All right, so after flying for 1 mile, so I also know that this distance that I have right here is 1 mile that it flew. The plane turns 90 degrees towards the northwest. So if you look, this is the northwest, this direction right here. And I wanted to make it look like the plane turns 90 degrees. So with that red line right there, I'm going to make a blue line, I guess. And I want it to be looking perpendicular to that red line because it turned 90 degrees towards the northwest. How do I know it's this way and not this 90-degree angle? Because it said towards the northwest. If it said southeast, then I would go that direction, but it's northwest. So I'm going to make a 90-degree angle right here. Okay. All right. So the question is state the new bearing. The new bearing is the direction that plane is flying, which the plane is right here. It's right there. So I want to know what direction that is. And it's from this origin right here. So I have to figure out what that angle is. Okay, so what I'm going to first start off by using is remember that this line and this, I should probably use my highlighter. This line and this line are parallel, and this right here is a transversal. So I do have alternate interior angles. I have 90-degree angles, so I can figure some stuff out here. Okay? All right, so because alternate interior angles are congruent, I know that this angle right here and this angle right here are alternate interior angles. So let me get rid of all my highlighted lines here. But this angle and this angle are alternate interior angles based on those parallel lines. So this is 65. This is a right angle, so I know this is 25. Okay. This is a right angle because we made it a right angle. It said it turned 90 degrees, right? Oh, no. So let me erase that box right there. So I know that this is 25 also because of that right angle. And if you want to keep that right angle in there, you can. And then I know this is 65. So I have enough information to find out what direction it's finding in. It wants both methods. I don't have to say which method's which, but I'm going to do the easier method, what I believe, first. So remember, I want to know what direction this is right here. Okay? So if you look, this is closer to north, and it's going towards the west. It's going 65 degrees towards the west. So one way to say it is north, 65 degrees towards the west. The other way, remember, is to use from north clockwise. So this angle right here. So I need to know how much that angle is. It's almost 360, but it's 65 less. So if I do 360 minus 65, I get 295. So the other way of saying it is 295 degrees. So either one, it doesn't matter. If it doesn't ask, it doesn't matter which one you give. But this one asks for both. All right. Next, it says, after the plane flies 3 miles in that direction, what bearing should the control tower use to locate the plane? So now I'm using this whole diagram again. I'm just going to copy and paste it. You could just draw directly on it, but I'm going to copy and paste it since these are notes, and I want to make sure that it is known that I am still using that diagram. Okay, I'm also going to get rid of this highlighter because I don't need it. All right. So after the plane flies 3 miles, so that means this blue line is 3 miles long. What bearing should the control tower use to locate the planes? Remember, this is where the plane is. The control tower is where we started. This is the control tower. They want to know what bearing the control tower should use to locate the plane. So what I'm going to do is I'm going to connect the control tower to the plane, and they want to know what's that angle. If you notice, we just made a right triangle. So to figure out what this angle is, what I'm going to do is I'm going to figure out what this whole entire angle is right here. I'll call it theta. Once I do, let's say that angle is 30 degrees. Well, I already know this is 25, so this would have to be 5 then, right? So if I can figure out that whole angle, then I can figure out what that little teeny tiny angle is right there, and I can get my answer. All right, so let's figure out what that is. Since this is a right triangle, I can use SOHCAHTOA. I have opposite, which is 3, and I have adjacent, which is 1. So opposite and adjacent use tangent. So I'm going to do tangent of theta is equal to opposite over adjacent. Opposite is 3, adjacent is 1. And now I need to solve for theta, which is my angle, so I need to get rid of tangent. To get rid of tangent, I'm going to use tangent inverse. So I'll tangent inverse this side, but what I do to one side, I have to do to another side. So I'm doing tangent inverse of 3 over 1, or just 3. I can put the over 1, but I'm not going to put it in my calculator. That'll give me theta. All right, so I do need a calculator for this. Let me pull up my calculator. Tangent inverse tangent inverse of 3 divided by 1, which is just 3. Hit enter, and I get theta is 71 point, what did it say to round to? Angles to the nearest tenth, 71.6 degrees. Okay, but that's not my answer, right? Because I just got that this is 71.6 degrees. So now I can get this little angle right here. So I'm going to do minus 25. And now I know this angle is 46.6 degrees. All right, so now I want to know what that bearing is. It doesn't say I have to do both methods. So I'm going to use my never eat soggy Wheaties method. And I'm going to say it's from the north towards the west, right? Like if you look at this angle right here, it's from the north towards the west. So north, 46.6 degrees towards the west. And that's the bearing they should use. You could have also, just as an FYI, I'll show it, but you don't have to do both. You could have also said what this angle is. So you could have done 360 minus 46.6, and you could have used the answer of 313.4 degrees. So that's also an answer that is allowed. Okay. All right. Next one. I'm going to move my calculator over a little bit, but I know I'm going to need it again, so I'm not going to get rid of it. Example 5 says, an observer stationed at point P can see a road between A and B, and I already drew that for you. The bearing from P to B is north 73 degrees west, and bearing from P to A is south 50 degrees west. Given PB is 3.4 kilometers, and PA is 2.6 kilometers, find AB. All right, so I have some drawing to do. It told me that the bearing from P to B, so that means I have to draw a compass at P so I can connect P to B. So I'm going to draw a compass at P. It says bearing, which is the direction. So if I need direction, I need a compass. All right, so now I need to connect P to B, like so. And it says that bearing, oh, my compass is crooked. I don't like it. I'm going to fix it. Is the other one crooked? Sorry. I just want it to like, the more accurate it looks, or the more accurate it is, the easier it is to like do these problems. All right, so it says that that bearing, that blue bearing right there, that direction that that blue line is going, is north 73 degrees west. So never eat soggy Wheaties. So it's from the north towards the west, 73 degrees. From the north towards the west, 73 degrees. I don't know why I'm changing colors. From the north towards the west, 73 degrees. And then I can fill out that teeny tiny angle right there. 90 minus 73 is 17 degrees. So I know that angle is 17 too. Probably going to help me later. Okay. All right, next it says the bearing from P to A. So the bearing from P, there's already a compass at P, so I don't have to draw another compass. I just have to connect P to A. Well, it's not over there. It's right here. It says it is south 52 degrees west. So from the south towards the west, 52 degrees. 90 minus 52 is 38, so this is 38 degrees. Now it says given PB is 3.4, so this is 3.4 kilometers. And PA is 2.6 kilometers. Find AB. So AB, I can call it X, or I can call it lowercase p. It doesn't matter. I'm just going to call it X because I like to. Okay. All right, so now I have to see what I have here. Okay, so I have this side. I do know what this angle is right here, 17 plus 38. I can do it in my head, but just so I don't make something stupid. Mistake. 17 plus 38 is 55 degrees. So this is 55 degrees. Let me do it in a different color. So this is 55 degrees. So I have that side, that angle, and this side. So I have side, angle, side. Side, angle, side is law of cosines. This is side, angle, side. So I can use the law of cosines to find this side right here. All right, so law of cosines tells you to start with the missing side first, which is great because that's what we're looking for. x squared equals, and then my other two sides squared, so 2.6 squared plus 3.4 squared, minus 2 times those two multiplied, 2.6 times 3.4, times the cosine of the angle opposite of that side, which is 55 degrees. All right, now I need to solve for x. If you notice, to get x by itself, all I got to do is square root. So I'm going to do square root of 2.6 squared. Be careful typing and make sure you're looking at what you're doing. Plus 3.4 squared, because you're not going to catch mistakes in the answer. You're not going to be like, that doesn't look right. 2 parentheses, 2.6, close it, open a new one, 3.4, close it, cosine of 55, close it, enter. And I get x, which is really AB, so I'm going to put AB equals 2 point, oh, wait, how do I round this? I round lengths to the nearest hundredth, so 2 decimal places. 2.86. Now remember, these are word problems here, so I want to either have degrees or whatever unit it's in. This is a length, it's in kilometers, so 2.86 kilometers. And it just said find AB, so this is done. I don't have to solve the entire triangle. Okay, one more left. A small plane is lost after leaving DuPage Airport. According to air traffic controllers, the plane first flew 72 kilometers on a 118 degree course. So I'm going to start by drawing that before I even read anymore. So according to air traffic controllers, the plane first flew 72 kilometers on a 118 degree course. So I'm going to draw a compass. This is north, east, south, west. And I need to draw 118 degrees. So from due north, I have to go 90 plus 28 more, right? 100, yes. So I'm going to go 90, which is this much, plus 28 more. And I'm going to get rid of that. I just know that it's in the fourth quadrant here. I'm draw it in different colors so I can refer to it as whatever color I pick. All right. So this here, and then that's 90 plus 28 degrees more makes my 118, and then 90 minus 28 in case I need it. 90 minus 28 in case I need it is 62. This is 62 in case I need it. But I might not, who knows? Okay, so that's good so far. I drew that already. It then switched. So notice it says it then switched to 150 degree course. That means new compass. So the plane was right here, but then it switched directions, so I need a new compass. So I'm going to get a new compass. North, east, south, west. Okay, so it switched to 150 degree course. So now I have to draw 150 degrees. So 150 is 60 more than 90. So now I'm going to pick a different color. I'll use pink. And I'm going to go, so 90 and then 60 more. So it's like right there. And then I'm going to get rid of that curve because I don't want it to confuse me later. Okay. And this is 60 degrees. And that would make this 30, just in case I need it. Once again, that's because this right here is 150, in case you're like, wait, well, how is that 60? All right, I forgot to put in the distances. So let's do that right now. This was 72 kilometers, and this is 58 kilometers. Oops, kilometers. Okay, so now it says, where all contact was lost. So let's start back from the beginning. A small plane is lost after leaving DuPage Airport. So this is DuPage Airport right here, just so we're aware. According to air traffic controllers, it flew for 72 kilometers on a 118 degree course that flew that purple line. Then it switched to 150 degree course for 58 kilometers. That's that pink line. So now the plane's right here. This is where the plane is, that little dot right there. All contacts lost. So now it says at what bearing and what distance from the airport should a search begin? So DuPage County Airport is looking for that plane. So let's connect that plane to DuPage County Airport. I should not use blue. I'll use red. Okay. All right. So there's DuPage County Airport looking for that plane. It says at what bearing and at what distance. So I want to know that angle, and I want to know how long that red line is right there. So let's see what we have so we can figure this out. Okay, so I know that I have this side and this side, so that's helpful. And then I know that I have to end up at some point looking for this angle, so there's no way I got it. I definitely don't have this angle. I definitely don't have this side because I have to look for it. So that means that I gotta have this angle right here. And I already have that 30. I know this is 90. And then that means I need to know what this is, and I have to know what it is. Remember, you have parallel lines when you have two compasses, so you're gonna use alternate interior angles. So let's see my alternate interior angle. So here's a parallel line, here's a parallel line, here's a transversal. This angle is congruent to that angle right there. So that missing angle that I said that I need to know, that's 28 degrees. Let me fill that in. This is 28. All right, so that means that this angle from here to here is 90 plus 30 plus 28, which is 148 degrees. Yes, 148 degrees. Now, if you need to see what this triangle looks like outside of this, just in case it's like confusing you a little bit, I'm going to draw it a little less oblique looking, or not oblique, obtuse looking. I know that this is 148, this is 72, and this is 58. So I can figure out this x right here. I can figure out that distance. Let's find the distance first, okay? I can do that because I have side, angle, side. All right, I have side, angle, side. I can use the law of cosines, and I'll call it x, and then I'll fill it in once I know what it is. So I have x squared is equal to 72 squared plus 58 squared minus 2 times 72 times 58 times the cosine of that angle, which was 148. To get x by itself, I'm going to square root. So I have x equals, and now I just have to type that in my calculator. So square root of 72 squared plus 58 squared minus 2 times 72 times 58 times cosine of 148. Hit enter. And I have x equals 125 point, and then distances, I wanted 2 decimal places. So 0 to kilometers. So this right here is my distance. My distance they need to search is at 125.02 kilometers. There's one of my answers. That wasn't very nice. Let's try that again. All right, the second thing they asked me for is what's the bearing that they should look at. Okay, so I want the bearing of this red line right here. Okay. Now, once again, I can, just like before, we did something similar, I can figure out what this angle is, right? Once I know that, then I'll know what this angle is, and then I can figure out the bearing, okay? All right, so let's figure out that angle is. Since we already used the law of cosines, now we're going to use the law of sines. I'll start with the ratio that I do know, which is sine of 148 over that 125.02, which I'm just going to call x for now. But remember, this is x. And then the one that I'm looking for that theta right there. So I'm going to do sine of theta over its opposite side, which is 58. And now I'm going to cross multiply and solve for theta. So I'm going to do x times the sine of theta is equal to 58 times the sine of 148 degrees. And then I'm going to get rid of the x by dividing both sides by x. I'm sorry, I'm not getting rid of it. All right, now I can solve for theta by sine inversing both sides. So I have theta equals sine inverse of 58 times the sine of 148 divided by that x value. Now, I should probably store this in my calculator because I don't want to lose it. Store as x. Okay, so I'm going to do sine inverse 58 sine of 148, close parentheses, divided by x, close parentheses, equals, and I get theta is, degrees are 1 decimal place, according to directions, 14.2 degrees. That isn't my answer, just so we're aware, because that's not the bearing. That's this, 14.2 degrees. So I know that this angle right here is 62, so I'm going to do 62 minus that to figure out the other angle in case I need it. 62 minus 14.2 is 47.8 degrees. So now I can get the bearing, right? Now I can get the bearing. The bearing is that red direction, right? It's closer to south. It's going towards the east. So this is south, 47.8 degrees towards the east, and there's my answer. Okay, I also could have used from north. So I could have also, let me use green here, from north, gotten this angle right here. So I could have done 90 plus 28 plus, oops, I forgot the 9 and 90. 90 plus 28 plus 14.2, and I could have put 132.2 degrees. So this is the bearing, and it's either one of these. All right, that's it for today with bearing and navigation.